Okay, functions trigonometry, chapter 5, section 3. The title of this section is functions trig functions of any angle. There's a lot of information involved in this section, so we're just going to get started on it on this particular lesson. But this is kind of what is hinge pin. And we need to learn how to define any right triangle as a simple ordered pair. What do I mean by that? Let's say that we're just given a point, -3, -5. How do we view that as a angle of rotation? And what we can do is we can imagine this is a right triangle. And we need to remember that the -3 is an x-coordinate, so that is really a distance to the left and to the right, and the y-coordinate is actually a distance up or down. So if we were to plot this thing, all right, this is where this point would be. Now, how did I get to that point? Well, I moved over left 3, down 5. And these two lines make a right angle, and then I can join it with a hypotenuse, and now I have a right triangle. And we had spent a lot of time solving this right triangle. Probably the first thing that we want to do is get a hypotenuse so we can get all of our trig functions. First of all, let me talk a little bit about this angle that is formed by an ordered pair. Okay, we call this the terminal angle. And the reason we call it a terminal angle is the side adjacent is always along the x-axis. And that's going to be very, very important for us. And I can draw a point in any of the 4 quadrants, and I can make an angle with the x-axis. So that's critical when I'm forming this little right triangle given a point. This is what we call the terminal angle. And it doesn't matter if it's the negative x or the positive x, but that side adjacent of our triangle has to be on the x-axis. Okay, so what does a typical problem look like? Well, we're given this point, and then we're given all this blah, blah, blah stuff. And all this blah, blah, blah stuff is saying is that terminal side of the angle theta. The terminal side basically means the x-axis, either the positive x or negative x. Okay, so what we need to do is we want to find the value of all 6 trig functions, and we also want to find the value of the angle theta. All right, the best way to do, you should really get in the habit of plotting the point, because it's really going to be important to see what quadrant we're in. Later on, you might get pretty good at this and be able to do it in your head, but I really highly recommend you just make a little sketch of the point. Right? So if I was to plot the point 1, 3, I move along 1 on the x-axis and then down 3 on the y-axis. And this is a critical point. The side adjacent must be the x-axis. So when I complete my right triangle, you notice my reference angle theta there is that side adjacent of 1 is along the x-axis. That is always how you need to make the right triangle. Now that I've got a hypotenuse, an adjacent, and a side opposite, I can easily calculate all my trig functions. All right. Let's do that. Here's our right triangle from our given point 1, -3. And this is what we did in 5.1 and 5.2. Right? All of our functions, make sure you rationalize the denominators. And there's our sine, cosine, and tangent. And then we'll go ahead and get the cosecant, the secant, and the cotangent. Okay, good enough. There's all 6 trig functions. Now, I also want to finish this problem up by finding that angle theta. That's going to be important. Right now, we're just going to find theta in degrees. So we have our calculator, And I can use the arc sine of this ratio. I can use the arc cosine of 1 over square root 10, or I can use the arc tan of -3. And when I do that, I get 71.6 degrees. All right, you might notice that some of these answers are positive and some of these answers are negative. Let's investigate that a little bit more. Why is that? Why are some of the arc trig function angles that we put in our calculator sometimes negative and sometimes positive? It's all the same problem. And depending on what trig function we use, we got either a positive or negative. Well, what that is due to is it's really going to depend on what quadrant we're in. Remember that our trig functions are ratios. And sometimes our sides are negative and sometimes are positive. It kind of goes from the fact that, a positive divided by a negative or a negative divided by a positive is going to give us a negative number. Positive divided by a positive, negative by a negative is going to give us a positive number. Okay, but what we can do is we can look at our point, and I know that if my point has a positive x-coordinate and a positive y-coordinate, I know that that plot is going to be in first quadrant, and every single one of my trig functions will be positive. Now, let's say the same point, same triangle, but my x-coordinate is now negative. Well, when I plot that, it's going to be in second quadrant. Now, when I'm in second quadrant, the only trig function that is going to be positive is the sine. And then when I get into the third quadrant, the only trig function that's going to be positive will be the tangent. And last but not least, here I am in the fourth quadrant. And when I draw my triangle, it's the exact same triangle, but just drawn in the fourth quadrant. It's now going to be only the cosine is negative. Now, how do I remember all this? Well, there's a cutesy little thing here. It's called No, that's another one. That one's dumb too. Okay, a smart trig class is one way to remember which functions are positive in which quadrant. Now, when you move on to the next course, pre-calculus, they like to say all students take calculus. Let's stick with a smart trig class. Okay, so how do I use that information? Let me back up. There we go. What does this tell me? This tells me, now let's say it says that I want to find the sine of, I don't know, some given value or whatever. Now, if that ratio or that angle is positive, then I know that that triangle has to exist in either first or second quadrant. What if they give me a positive tangent of a ratio or of an angle? Again, I know that that triangle has to be either in first quadrant or third quadrant. All right, so this trig functions being positive and negative in certain quadrants, that tells us when I'm given an ordered pair or if I'm given an angle, I know which quadrant to make my right triangle in. Okay, this should be enough then for our assignment. And we're going to do the first one together. All right, so this is what we're given. A -4 for the x-coordinate and a 3 for the y-coordinate. I'm going to show you a little trick. This is going to shorten your work. This is always going to be my side adjacent. This is always going to be my side opposite when I form my triangle. Get in the habit of quickly just making a little sketch. Draw your little x-axis, plot your point, draw your side adjacent, draw your side opposite, and then throw in the hypotenuse. The hypotenuse is always going to follow this formula. All right? Now, where's my angle? My angle has to be formed with the x-axis right there. Now I can just do all of my trig functions, and then I've completed the problem. And this assignment is all very similar, or some sort of slight variation of this type of problem. Okay. And then let's go ahead and find the angle. I used the arc sine function. I could have used the arc cosine. I could have used the arc tangent. It's going to give me 37 degrees. Now, sometimes it'll be positive, sometimes it'll be negative. What do I use? Don't really care. I know that 37 degrees is an angle formed with the x-axis. What we call that is the terminal angle. Doesn't matter whether I call it positive or negative. I know it forms with the x-axis. All right then, that should be good to go for this. Happy Thanksgiving.